Muted.
Yeah, okay. So good morning everyone again. Now what I was telling is that today we'll cover overloading, method overloading, polymorphism, uh, overloading constructors, and how to pass objects to a method, or how you can pass objects as method parameters, and two types of method argument passing. Okay. So let's see. Last class we did. We learned about constructors and this keyword, right? So let's get started. So what is method overloading? Okay, before understanding overloading, let's see uh, what is method overloading. Then we will compare that with what is overloading. Okay, so we've seen multiple times that we've written few methods with the same name, right? Few methods in a class with same name. Okay, but when we wrote methods like that, there are some differences. So what are those differences? So there was like parameter differences were there. Okay, from one method to other method. For example, one minute, give me a second, please. The pen is not working. Yeah. Okay, now it is okay. Okay. So what we are discussing is method overloading, right? So we had some methods. For example, sorry for the. Give me a second. Sorry, the pen is not working, so that's why I'm just checking. Sorry for the inconvenience. Okay, so for method overloading, we had I mean in couple of examples we had the same method name but with different parameters. Okay, say for example, if I have a method by name test, okay, without any parameters, we can have another method with test with parameter change. Okay, and like this. Okay, same name, but we are passing different parameters each time. So we can have another method with name double D and int A. Okay, so multiple methods with same name, but their parameters differ. Okay, so that is what is called as our method overloading. Okay, this is called as our method overloading. Okay, method overloading is nothing but we'll define same method name but different implementation. Okay, how do you do different implementation, or by passing different parameters to a particular method. Okay, so the only condition that we need to remember about with respect to method overloading is their parameter declaration should be different for each method. If you want to overload a method or give different meaning to a method for the, with the same name. So the only condition is the parameter declaration should be different for each method. Okay, parameter declaration should be different. That is when we call it as method overloading. This is similar to our English words, right? Say for example, we have English word write. Okay, we have English word write. It can be right turn, or it can be right or wrong, right? Sorry. Okay, it can be right or wrong, or it can be right turn. Depending on situation, the correct meaning will be deducted, right? I mean, in the sense, correct meaning we will use it. So when we are driving a car and if you want to take a right turn, we say take right turn. Okay. So when somebody is right, we will say, yeah, he is with respect to this particular thing, he is right. Okay. Based on the context, we derive the meaning of a particular word. Okay. So what we can say, right is overloaded. Overloaded with different meaning. Okay. Right is overloaded with different meaning. In this case, right turn, in this case, it is right or wrong. Right. Similarly, rose. It can be a flower or past tense of rise. Okay, past of rise. It can be rose, can be a flower, or it can be a, in past tense. So you can use it as rose, right? Or you can use crane. So you can think of so many words in English, right? So many words in English. Crane. Okay, it can be which is used for lifting the objects, or it is a bird, right? Those. So what I'm trying to tell here is the words, how words are given different meanings. Okay, same word but different meanings. That is what is meant by overloading, or you can say word overloaded with different meanings. The same word is overloaded with different meanings. Similarly, what we are doing here, we will give or we will pass different parameters to the method with same name. Okay, important thing is method with same name. Okay, method with same name. We are talking about methods with same name. Methods with same name. We can write methods with same name in a class, but the condition is this one. Where is it? So the condition is this one. Okay, the condition is this one. Their parameter declaration must be different. Okay, and that is when we call it as method overloading. So method overloading is one of the way in which polymorphism is implemented in Java. Okay, polymorphism is what? You use the same thing, but to represent the same concept in different ways. To represent same concept in different ways is nothing but your polymorphism. Okay, same form. Say for example, you take a bottle. Okay, you can pour inside bottle. You can pour it. You can pour water. You can pour milk. You can pour Coke, whatever it is. But we are using the same bottle, right? But whatever we are, I mean, whatever the bottle is used to contain is different. Whenever you pour water, or whenever you pour milk, or whenever you pour Coke, or whatever it is, any liquid for that matter, right? It is similar to that one. We will try to explain the same concept in different ways, or same concept implemented in different implementations. Okay, that is what is your overloading method. Okay. So how does Java resolve overloaded methods? Okay, let us take an example. Let us take an example and let's see. Okay. Okay, let us go to this particular one. Okay, so here what we have done, this class is method overloading. Okay, so what we have done here, we have test method. Okay, we have test method. It doesn't take any parameters. Okay, and this is a test method. It takes an integer parameter. Okay, here it takes a double parameter. Here it takes two parameters, double one and double two. Okay, but remember the name of the method is same. The name of the method is same. Also, we have a void return type here, but here we have double return type. Okay, when we are overloading a method, the main thing to consider here is the parameters passed to the method. Okay, parameters or arguments passed to the method or the declaration of your method, which is called as your signature, method signature. Okay, so okay, so the name of the method is same, test, 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 and test. Okay, but here no parameters, integer, double, double, double. Okay, so here we have double return type. We have return type. Okay, so for whenever you define any method, we will define the return type, right? We will return the return type and then method name and parameters, right? Okay, the only thing to consider here is the parameters, differences in parameters. We will not consider type, return type of a method. So when resolving the overloaded methods, when Java resolves overloaded methods, that is when Java, like we derive the meaning of different English words based on the context, right? We derive the meaning of English word based on the context. For example, right, as I told, right, based on the context. While driving, if I want to take right turn, I'll say, okay, take right turn. Okay, or when someone has told something right, you will say, yeah, he or she has told right. Based on the context, we will derive the meaning of the word. Similar to that one, how Java resolves or how Java recognizes which method to call. Okay, how Java recognizes which method to call when a particular method is called, when a particular overloaded method is called, is determined by the parameters or arguments that are passed to the method while calling it. Okay, we have defined method here, but when calling the method, we use like, okay, test on a particular object, right? Test on a particular object. On a particular object, we call test. Okay, so when calling the method, whatever the values that we pass, right, they are called as arguments. They are called as arguments. Okay, so based on the number of arguments and type of arguments that are passed while calling the method, corresponding methods will be called. Okay, corresponding methods will be invoked. Okay, based on the arguments, type of arguments, and number of arguments that are passed, corresponding method will be invoked. For example, if I call test on an object without any parameter, this method will be called. If it is an integer, this method will be called. If it is a double, this method will be called. If I am passing two double parameters, okay, this method will be called. Let us see the same example what we are discussing. Let us erase everything. So what we have done here is, so what this is a method. Okay, so we are calling without arguments. Okay, so here we are calling with integer. Okay, here we are calling with double. Yeah, different parameters. Correct here. Same name but different parameters. Right? That is what is called as method overloading. Okay, these are the important, very important concepts which we should remember. Okay, so yeah, so we are calling. So let us see. Let's try to execute this program. Let's try to run this program. Then we will come to know. Okay. So what is happening? Test without parameters. Okay. Test method without parameters. Let me bring this. Okay. So what is this? Where is this? We are calling first. What am I doing here? So I am doing like I am calling. So on this particular object, okay, method overloading. I've created a method overloading object. So that is nothing but our method overloading class itself. Okay. So on this particular object, I am calling because we have defined all these methods, test methods inside this class. So I'm calling on this object. I am calling test method. So it invoked test method without parameters. Okay. Then I'm calling test 10. So it invoked method with integer as parameter. Okay. Here I'm passing double. So that is why it shows double parameter. Okay. 20.2, 20.20, it is 20.2. Okay. Now what else I can do is okay. So now I'm calling the double this method with double parameters. Okay. So double parameters is our double parameters, right? This is the method. So one important thing is to clearly differentiate. So this is one important thing. So these are arguments. Okay. Method arguments. These are method arguments. These are method arguments that is values passed to methods. While calling, okay, while calling, not class, calling, okay. These are arguments, and then not sure. Okay, so we have these things while defining a method or declaring a method. We specify these things. Okay, so these are called parameters. Parameters will have type, and parameter is nothing but type and identifier. Type and identifier. Type and identifier pair is a parameter, but the value that is passed while invoking a method is called as arguments. Okay, while invoking a method is called arguments. So that's what we are doing here. So here we are calling the method with two double arguments, that is 20.5 and 30.6. Okay, so that is why it invoked addition of this method. Okay, so I'm just printing this as addition of D1 and D2. Okay, so but one interesting thing to note here. Okay, so here what am I doing here? These are not doubles, right? These are not doubles, and we don't have a method with which takes double, integer parameters. These are integers, right? 20 and 30 are integers, right? 20 and 30 are integers, but we have not defined any method, any test method that takes two integers as parameters, right? Two integers as parameters. We will see why. Okay, so interesting to note here is which method did it call? it called this method, which takes double as parameters. Even though we have passed integers, Java called this particular method. Okay, this particular method. Okay, so we will see how that resolution is done, or why that particular method is invoked. Okay, so let us move to this one. So let us try to understand how exactly Java resolves these methods. Okay, how exactly Java resolves these methods. So when an overloaded method is invoked, Java uses type. It is and or. Okay, and or. Or is also there, not and or number of arguments to determine which version of overloaded method to use. Okay, which version of overloaded method to use. These are all different version of overloaded method, right? Say for example, sorry. These are different versions of methods, test overloaded methods, right? Different versions of test method. Okay, so which method will be invoked based on the type. The type will be like it's of I mean not exactly utilized. Okay, only thing that is considered when method to resolve method is the number of parameters or arguments passed. Okay, number of arguments to determine which version of overloaded method is used, which version of overloaded method to use. Okay, or to invoke. Difference in return type alone will not be sufficient. So if you say if you try to write a method, like this, if you try to method okay, if you try to write a method like this, you can easily see it says duplicate method. Okay, the only difference here is void and int. That is the return type of this method. So the return type alone will not kind of like will not be used to differentiate between the methods, overloaded methods. We are talking only about overloaded methods now. Okay. Yeah, that is what data type of number of arguments also. Okay, so not only data type, so number of arguments also. Here we have, right, say for example, let us see what exactly happens. I'll show you one example. Okay, so the return type alone will not determine whether the will not be used for overloading. Okay, type alone will not be used for overloading. It is the number of parameters and the data type. Okay, so here we can see that it says the duplicate method. Okay, even though we have the return type, different return types here. Okay, so let us comment this. Okay, and so for data type, so we have one example here, right? So this one we have two doubles. It takes two doubles, but here we are passing integers. But it again called this method, which takes double parameters, right? So okay, so how they are resolved? So the return type alone will not be used for sorry. Return type alone will not be used for resolving your give me a second. Used for resolving your methods. Okay, while invoke which method to call. So how Java resolves? It determines the version based on the parameters, number of parameters, and the type of the parameters. Okay, type of the parameters. So only thing that is used for determining your version of method, overloaded method, is parameters or arguments passed. Number of arguments passed, number of arguments, and the type. Type of the arguments. Okay. So let's move to the next slide. So while overloading, while resolution or which version of the method to call, return types do not play any role. Okay, and method is resolved based on the arguments passed with the declared parameters. But there is one more important thing to consider, that is automatic type conversion. So we have seen, right, automatic type conversion, how byte, short, char are converted to int, right? We have seen those things, type conversion. So those things also take place, or those things are also considered while resolving which version of overloaded method is called. Okay, which version of overloaded method is called, and resolving which version of overloaded method is called, Java uses type conversions also. Okay, but the main thing is it uses automatic type conversion only when no exact match is found. It uses only when exact match is not found. This is very important. Okay, otherwise if the exact match is found, it will not call at all. It will not use automatic type conversion. Okay, automatic type conversion it will not use, but when there is no exact match, it will use type conversion, automatic type conversion. Okay, let's see how that is done. Okay, so we have this particular method. Okay, so here we are passing integers, but it is calling double. Okay, it is calling double. So we don't, why it is calling double? Because we don't have a method which takes two integers. Okay, which takes two integers. In this situation, what is happening? These two integers are converted into double. Okay, these two integers are converted into double. That is why you see the result as 51 here. Okay, that is 20. What is it? Okay, so 20, 30 is 50. Okay, 20 and 30 is 50. That is why 50.0, it is converted into 20 and 30 are converted into 20.0 and 30.0, and then they are added, and the result is displayed here, 50. But since we have double method which takes doubles, this is also calling the double. Okay, let us try to do some simple modification here. Okay, let us add, let us see int. Okay, int. Okay, so let us see what exactly is the result. So here you can see, say, let me type this. Okay, so now you can clearly see. Okay, earlier case there was no exact match. Okay, earlier, before there was no exact match. That is why these two values, that is your 20 and 30, were converted into doubles. 10 and 20, that is integers, were converted into automatically type converted into doubles, and this particular method was called because there was no exact match, in the sense like there was no method which was exactly matching, which takes integers as parameters. Okay, that is why double was used initially. Okay, but here after defining this, you can clearly see, okay, method that takes two ints, that is two integers, this method is called, because the second case here it found the exact match for the number of parameters, and the data type, that is integers, exact match, right? That is why this particular method is called in the second case. Okay, so Shravanti is asking, Yeah, we will see that on Shravanti. Yeah, yeah, we are talking about overloading only, right? So method overloading, whatever the concepts that apply to methods, right? Most of the concepts apply to your constructors. Okay, so whenever we are talking about method overloading, definitely it applies to constructors also. We will see all those things. Okay, we have seen here, right? Overloaded constructors, object parameters, argument passing, all those things. We have all the topics in the upcoming slides. Okay, so we'll see all those things. So do you did all of you understand whatever the concepts that we discussed just now? Okay, anyone has any doubts? So overloading, same name, different parameters. Okay, and then we use automatic, or Java uses automatic type conversions. Java uses automatic type conversions while resolving methods. Okay, so this is similar to our language itself. As we discussed, we have write, words like write, rows, crane. We can think of so many words with different meanings. So here what we say, words are overloaded with different meanings. Okay, words are overloaded with different meanings. Similarly, here what we are using, same name. We are using the same identifier. We are using the same identifier for methods, but we are doing different things here. But one more important thing to remember here is, we should always do such things with related actions. Related actions, okay? We will see that one with related actions. So it doesn't mean that we cannot write. So what we are doing here? So here just is we are just passing and then printing that value. Here we are adding it. Okay, here we are adding it. So what we are doing here, just displaying, but we are returning a value, and after the sum of these two values we are returning to the calling routine. Okay, this is our usually in computer terminology, methods, functions, everything, right? They are called as subroutines. Okay, I mean before the term function, methods, all those things were coined. They were, I mean, some other languages they still call it as subroutines. Okay, in assembly language we still call it as subroutines. Okay, whatever the functions that we are writing here, similarly we can write uh, functions, if we can call them in assembly language as well. Okay, they are called as subroutines. In system programming and all, they call it as subroutines. Okay, so so here what we are doing, we are calling a method. Okay, this piece of code becomes calling. Okay, this is the called one. This is the method which is called. Okay, here we are calling, this piece of code is calling for this method. This is the method that is called, caller and calling. Okay, that's what I wanted to tell. So let's move on to the next one. So we know automatic type conversion when it is used. So important thing to remember about automatic type conversions is that is done only when no exact match is found, when the exact match is not found. exact match is not found. Only when exact match is not found. Okay. So now we will see there are different things, right, for object-oriented programming. One is your encapsulation, inheritance, and polymorphism. Okay. So encapsulation we have seen. So any block of code. Okay. Any block of code that defines, that is a basic form of encapsulation. Okay. Why? Because any variables. Okay. Any variables or objects that are defined within a particular block. Okay, particular block that is defined using your curly braces or flower brackets. Okay, that defines a block of code, and it also defines the lifetime. Defines lifetime and the scope of variables. Defines lifetime and scope of variables. Right. That is why whenever you define a variable or declare a variable within a particular scope, it will not be available outside, or it will not be visible outside of that particular scope. So what we are trying to do, we are trying to hide those variables within the block of code, okay, within flower brackets or curly braces. So that is where, that means we are encapsulating the data hiding, okay, that is your encapsulation. So second term is inheritance. We will see in after on Monday we will see what is inheritance, okay, how that is implemented. The third important concept with respect to object-oriented programming is polymorphism. Okay, so what is polymorphism? We use the same interface. Okay, we use the same interface. That is the name of your method, which we saw earlier, right? That is test. Use the same interface, but multiple methods, different implementations. Okay, different implementations. For example, we represent the same concept with different implementations. For example, to add integers, okay, to add integers, I have a method called addInt, which takes integers as parameters. For adding float, I have a method called float, which takes floats. For adding double, we have addDouble, which takes 2 double parameters. For adding string, which is nothing but concatenation, so we have 2 strings, which returns concatenated string, right? But what is the action that we are doing here? What is the action that we are doing here, or what is the actual thing we are doing here? We are adding 2 numbers, right? We are adding 2 numbers. Okay, for adding 2 numbers, do we need all these things? Add int, add float, add double, add string, add char, add byte, add short, add long. Do we need so many methods? No, because what is the concept we are trying to express here? Addition. Right? We are trying to express addition. So what we can do? Add int, okay, and then add float. Okay, so same name, we can use the same name. Sorry about these things. So we can use the same name, add, right? We can use the same name just by passing different parameters to it. Okay, just by passing different parameters, like we did for test method, right? Like we did for test method. So what is the important thing that is that we need to notice here is we are trying to represent one particular concept, that is addition. okay, on particular action, that is our addition, okay, in different, by passing different types of parameters, different number of parameters, and different types actually, okay, number and different types, okay. So as you observe here, we need not have to have these many different names represented for the same action, okay, different names represented for the same action. We can have, how we can do that? We can achieve this by using method overloading, by giving same name and by passing different parameters, right? This is what is called as your polymorphism. Same interface, multiple methods, okay? So we have multiple methods here, but the interface here, interface is the name of the method, okay? The name of the method. The name of the method is our interface, okay? Did everyone understand what is polymorphism? How polymorphism is implemented? Polymorphism is this concept, same interface, multiple methods. The implementation of polymorphism is method overloading, the one which we are talking here. So if somebody asks how polymorphism is implemented in Java, you can say method overloading. Not only method overloading, constructor overloading. Okay, so overloading, you can say overloading. It can be method overloading or constructor overloading. There is one more implementation that we will see later. Okay, when we discuss about inheritance, we will see those things. Okay, so this is what is your method overloading and polymorphism, implementation of polymorphism. Okay, yeah, we will see Kavita. Kavita is telling static. Okay, we will see Kavita. Okay, so let's move on to the next slide. So what are the advantages? So what are the things that I have mentioned here, we have already discussed. Okay, so what are the advantages? Excuse me. What are the advantages? So we use same common name instead of multiple names like addition, add int, add float, add double, add string, add byte. We can just use add, okay, by passing different parameters. So we are using only one common name. Okay, here they represent add. Add represents, or addition. You can say add or addition represents one common action or general action. One common action. Okay, it represents a common action. So that is what we change the names to add or addition instead of add int, add float, add double, or add strings or something like that. Okay. Through the application of this polymorphism, several names can be reduced to one. This is one of the advantages. We need not have to remember so many names. For example, in C, for finding the absolute of integers, we have this one. Okay, abs method. Okay, for finding the absolutes of longs, we have labs. Okay, so for finding the absolute of floats, we have tabs, because C doesn't support method overloading. So each and every method should be different. Okay, each and every method name should be different, or function name should be different. So what is happening here? If you are learning C, you have to remember all these names. Whereas any language which supports method overloading, you can overload all these things with name as, okay, by just passing different types of parameters. That's it. So what advantages it is giving to a programmer? You need not have to remember all three names. You can just remember only one name. That is, the names has been reduced to one. So we are talking about one particular action here, right? One particular action, that is finding an absolute of a number, or addition of two numbers. Okay, so it is not mandatory. It is not mandatory to do same action for overloaded methods, or overloaded methods need not have to do the same action or same concept. They need not have to implement the same concept. Okay, you can you can have any other implementation. If you want to do two things, right? Say for example, let me take an example here. Okay, this is the one which I was trying to explain. Okay, we have methods add int, add float, add double, add string. Okay, so different methods are there, but what we can do, we can kind of like use method overloading, right? So what we can do, public, let us make it as void, add two numbers. Okay, we will display here itself. We will not return it, just display int A, int B. Okay, and then we can have if you do Control Shift F, the whole thing will be formatted accordingly. Okay, so indented. The file will be formatted accordingly, like proper with proper indentations. Okay, Control Shift F. FLOAT, FLOAT. Okay, and then double. Okay, so you can see. So just by remembering one name, addition, add or addition, we can do various operations, right? Same operations, whatever we are doing here. So also what we can do is add. Okay, here assume that I am doing addition here. Okay, for example, I'm doing char A, char B. Okay, it is not necessary that I should return the addition of two numbers. Okay, I can do return A star B also. Are you getting what I'm trying to explain here? Are you all getting what I'm trying to explain here? Here what I'm printing? Addition. Okay, we are trying to express addition here. Right? We are trying to express addition in all these things, right? By giving one, by using one particular interface, name of the method. Okay, by using one particular interface, and we are providing different implementations. One takes double, one takes float, one takes integer. Here it takes character. Okay, individual character, but the name is same. Here we are all trying to add two numbers, but here I'm trying to multiply two numbers. Okay, so what does that mean? When we are trying to trying to overload, right? When we are trying for method overloading, you need not have to provide whatever you are trying to express. So same, it need not have to, or you need not have to implement what you are trying to express. That is addition here. You can give different implementation also, like multiplication, division, whatever it is. In real life, you can give any implementation, but generally method overloading is done for such scenarios, for expressing one particular action or concept you are trying to implementing multiple ways. Trying to implement in multiple ways. Okay, that is when we use method overloading, not in these scenarios. Okay, normally, but this is also possible. Method overloading does not mean that you have to provide the same implementation for all the things. You can provide different implementation. Which if you say add, you can give multiplication, division, or subtraction, but that is not how we normally use it. Okay, that is what is the point that I wanted to drive here. Okay, so hope everyone understood what I was trying to explain here. So if you have any doubts, please let me know. we'll try to address that. Okay. So, okay. So, Kavita was asking constructor overloading. Yeah, we can overload constructors as well. We have seen one or two examples in our previous classes, right? One or in previous session, one of the previous session. Okay. So, how do we overload constructor? And here, when we talk about methods, obviously the return type will come into picture. Okay, obviously the return type will come into picture, but we will not consider the return type. Java will not at all consider the return type when resolving the version of method that is invoked. Okay, when we come to constructors, there is no return type at all. The implicit type is the class type itself. Implicit type, it returns is the class type itself, in which it is defined. Implicit type is the class type itself in which it is defined. That is, it creates, and when you use new operator, what it does, it allocates memory, constructs the object and returns a reference to an object of type defined by this particular class, right? That is why we call it as implicit return type of the constructor, right? Implicit return type of constructor is the class type itself. Okay, but we explicitly don't specify anything like it returns this particular thing or something like that. When you try to explicitly tell like return specify the return type, that becomes a method. Okay, and when overloading constructors, we don't deal with return types at all. We are not specifying explicitly any return types for the constructors. So that becomes very easy. So let us take an example how that we can implement in Java. Okay. So how constructors can be overloaded? Let us see. Okay, take an example. So we have a box class which represents our box. Okay, any box. It can be any box. Okay, Amazon box or whatever it is, a package box. So it will have three parameters or three instance variables, height, width, and depth. Okay, we have three things here. Okay. Okay. Length, width, and height. Length and width. Okay. Length, width, and height. Okay, that is what we have represented here. So how the constructors can be overloaded? We can define one particular constructor which does not take any parameters. That is our default constructor. Default constructor. Okay, that is our default constructor. If you want to specify all the dimensions, length, height, width, all those things, you can have another constructor to create an object with specified dimensions. Okay, so this is another constructor which is used for creating a cube, which will have same length, breadth, and other stuff. Okay, cube. Okay, so this is how normally in real world examples, right? In not real world examples, in real world applications, constructor overloading is very common. Okay, constructor overloading is very common. This is how we use constructor overloading. Okay, this is how we use constructor overloading. So to give different things, let us try to run this particular example. Okay, what we are doing here, I have defined box class there. Okay, I have defined box class there. This is our box class. Okay, so I am creating an object of boxes here. Okay, creating an object of boxes here, and I'm trying to print what it contains. Okay, what it contains. So there is one important thing that I will explain it just now after executing this particular program. Okay. So let me run this program. So this is our code. This code is calling the methods in this particular code, right? Or this one, what is that constructor? Let us try to run this. Okay. So you can see the default constructor, right? This is the dimension that we have specified. That is 0, 0, 0, because we are using constructor without any parameters. Okay. So this is our constructor without any parameters. That is our default box. Okay. This is our cube. Okay. So with length, width, height, and all the 3 dimensions as 10. Okay. Which constructor it called? It called this particular constructor. Okay. Third one is we have specified all the dimensions here. 1, 2, 3. Okay. That is our normal. That is when this particular constructor is called. Okay. So that is how you can overload constructors. So this is one simple example. Okay, how you can overload constructors. And one more important thing is we have seen, right, whenever we try to we have seen one thing, like how concatenation operator operates. Whenever one of the parameters or operands, when one of the operands is string, the other operand gets converted to string, and then it is appended or concatenated with the other string, right? So how does that happen? There are different things. So one simple thing is we can define one particular class or one particular method called toString. Okay, we can define one particular method called toString, which returns string, and it has to be public. It has to be public. It returns string, toString method. Okay, toString method. So if you see here, whenever I am trying to print box, right, I'm not trying to do anything here. Whenever I'm trying to print box, I'm just trying to print box. Okay, cube. Okay, and normal box. It is getting converted into with string, of course, with string. Okay, this becomes concatenation operator. It is displaying the dimensions here. How is it displaying the dimensions? Let us try to uncomment one particular piece of code. Okay, let us see. Okay, so you can see box objects toString method, box objects toString method, box objects toString method. Okay, so let us try to comment this whole part. Let us see what exactly happens. Okay, so now let us see what happens. See, you can consider this as the references to those objects, those 3 objects. Okay, so this is a reference for this object. This is a reference for this object. This is the reference for this object, not just this part, the whole thing. Okay, reference. That is why these are all called as references to a particular object. Okay, of type box. But if you want to convert, right? So here, what am I doing here? I'm trying to. Where is it? I'm trying to print it. Okay, so this string I'm trying to concatenate. If one of the operand is string, whatever is there in this, right, that gets converted into string and appended to this one. That is what is happening here. Okay, that is what is happening here. The object reference is converted into string, and then it is printed. Okay, that is done using default toString method that is provided by Java. Default toString method that is provided by Java. So whenever one of the operand is string, the other operand gets converted into string by calling toString method provided by Java. But we can override that. That is, yeah, we will see that one later. Overloading. We usually get confused. Okay, overriding happens when in case of inheritance, but overloading is within a class. Okay, we will see that one. So we can override. It is not overloading. It is overriding toString method. Okay, we can define a different or we can try to print it in a meaningful way, the object in a meaningful way, by providing a different definition to toString method signature, public string toString. It doesn't take any parameter. Okay, so let us try to print the same thing again. Then that particular method, whatever toString method we have overloaded, right? That particular toString method will be called to convert this object into string and then append it to empty string. Okay, did you all get what I was trying to explain? Just to explain toString method. So this toString method, right? In real life, so the objects, whatever the classes that you see in real life, right? In real life applications, they will be very, very complex. Okay, so in order to whenever you try to print the object, right, with the string or print it, usually what we provide for every class, whatever the user defined class, we define toString method. Okay, we overload the toString method and provide meaningful strings based on the need. Okay, meaningful string for each and every class, that user defined class. Whatever the class that is defined, we will try to provide a meaningful string representation of that particular object. So similar to this one, whenever I try to print here, right, it gives whatever the dimensions that are there for that. Okay, whatever the dimensions. Okay, whatever the dimensions. Similar to that one, for each and every class, it is a good practice to have toString method for each and every class that we define. Okay, that is a good practice to have. So whenever you try to print it, that object, right, you'll get what exactly is happening or state of that particular object with these things. Okay, so that is what is our constructor overloading. So till now we've seen passing only primitive data types to methods. Okay, so it is valid and it is exactly correct to pass objects as arguments to methods. Okay, objects as arguments to methods. Not only primitive types, we can also pass objects as arguments to methods. Okay, so we'll say that one here. So let us see one example here. So what is happening in this? We have one particular method here. So it says this is our equals method. It returns Boolean and it takes two objects, box 1 and box 2. Okay, it takes two objects, box 1 and box 2, and determines whether those two boxes are equal or not. Okay, whether those two boxes are equal or not, it determines whether those two boxes are equal or not. Okay, how that is determined? By checking the height of one object with height of other object, height of width of other object, and depth of other object. If all are equal, it is an AND condition, right? It is an AND condition, and this is our relational operator, equality. We are trying to check equality of each value. If all are equal, then we will say return. Otherwise, we will return false. Okay. So we have created two box objects with default constructor. So default constructor here, what we are trying to assume? -1, right? So let us try to run this program and see. So it shows the dimensions are -1, -1, -1, -1, -1, -1, and then both are equal. Right? Let us try to create another object. Okay. Box cube is equal to new box of some 10. Okay. Now try to pass these two objects. Let us try to pass cube. Okay. Okay, we'll not discuss about this now. After a couple of minutes, we will discuss this. Okay. So let us say we are trying to say whether if it is true, the result of this equals operator, that our equals method, that is Boolean, right? We are returning. If it is true, okay, then we will get boxes cube and cube are true. It does not. copy dot equals. Okay, so it returns true or false. Let us try to compare these two things, cube and B, object B. Okay, so it says the dimensions are height, width, and this one. So both are equal. So both boxes are equal. Okay, but second case, height, width, and the depth is 10. So here the box B dimensions are -1, so they are not equal. Okay, are you all getting what we are trying to explain here? We can pass objects as arguments to methods, similar to how we pass primitive data types. Okay, so here we are passing objects. Okay, so there is one more way of representing this. Okay, we can define equals method. We will see toString method, from where we get this toString method, equals method, all those things. Okay, so this is another way. So where is this equals function defined? It is defined here. Okay, it is defined here. The logic is same. The logic is same. What we are trying to do here, this is a member of box class itself. This is a member of box class itself. So we can invoke that method on any box object. We can invoke that method on any object by passing another parameter or argument of same type. Okay, which does the same thing. This is one. This I just wanted to show you how to pass two arguments here. But here, what we are trying to do, we are trying to pass one box object, and we are trying to compare with the one which is invoking. Right? This represents the object that is invoking, and this represents the object that is being invoked as the argument passed to this equals method. Okay. Are you all getting? Are you all understanding what I'm trying to explain? Please let me know if you get confused or if you are getting confused. Okay. So not only primitive data types, we can also pass complex data types as parameters or arguments to a method. You can define any method by passing complex types as parameters while defining. Okay. Here we are passing arguments. Okay. Okay. Anyone has any questions or any doubts? Do you have any doubts? Please let me know. Anyone has any doubts? Okay. So let's move on to the next topic. Okay. So we have seen passing parameters to methods, right? Parameters can be either or arguments. Parameters defined within a method or arguments being passed to a method while calling the method, right? They need not have to be primitive types. They can be objects as well. Okay, based on what type of parameter is passed, whether it is a primitive type or the complex type. We have two ways of handling those things. Java handles method argument passing in two ways. One is call by value. Okay, this call by value is always applicable whenever the primitive data type is passed. Okay, whenever primitive data type is passed, call by value is used. Okay, what is this call by value? So whenever you pass the primitive type or primitive value while calling, right? While calling a method, so if you try to change that primitive the value that is passed to a method within the method, okay, within the method, that value will not get changed when you come out of that particular method. Okay, that is what happens here. So it just copies the value of argument to the parameters of method. It simply copies the values of argument. Simply copies the values of arguments. Okay, simply copies the values of arguments. Value of argument is copied to the parameters of the method. Okay, say for example, I have test int a. Okay, and I am passing in I is equal to 10. So while calling, I'm passing 10 here. Test 10. Okay, while calling this on some object. What no, I'm not passing 10 here. I'm passing I here. I'm passing I here. So what is happening? The value of I is 10. Okay, that value is copied to A. Okay, when you change A is equal to A plus 10. Okay, A is equal to A plus 10. This will become say 20 if we take A as I as 10. Okay, but this value will not affect the value of I here. They are totally independent of each other because we are just copying the value of I and passing it to the method. And whatever the change that you do, this is a parameter, right? This is our parameter, method parameter. So whatever you do to this particular variable, that will not get reflected reflected in your I. That is our argument passed to test method. That is what is happening here. That is, Java copies the value of argument to parameter. Okay, changes made to the parameters within the method will not have any effect to the arguments passed. This is the argument which is passed. This is the parameter which is getting changed, right? So it will not have any changes to the argument that is passed. That is your call by value. So this is applicable, or this is used in case of primitive data types. Whatever the primitive data types that we discussed before, this is used for primitive data types. Okay, call by value is used for primitive data types. But there is one more way, that is call by reference. So we have seen how references look, right, in the previous example. So yeah, Kavita is telling A dot equals of new box. Yeah, we can always tell like that, Kavita, correct. So anything, I mean, you can say, Kavita is telling A in the previous example, right? New box. We passed two objects, right? I can call like this also. This is calling your default constructor with -1. So whatever the things that you are passing here, right, that will have different dimensions. So if both are equal, it will be true. Otherwise, it will be false. So call by references. This is used for our complex objects or objects, complex objects, complex types or object types. Okay. So how that is done? A reference to an argument is passed to the parameter. Okay. Say for example, I have a box object. Okay. Box object B is equal to okay. Assume that B's reference, the one which it reference which it contains is A, B, C at the rate some 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the reference which is inside this. Using this reference, we access instance variables of this particular object. Okay, I hope all of us are clear with respect to these concepts, reference and accessing values through references. If you have any doubts, please let me know. I will explain it again. Okay, at the rate, this is the reference through which is used to access instance variables, values of instance variables, or state of a particular object. State of a particular object. State of a particular object. This is the reference. Okay, say it is ABC. Some at the rate 1, 2, 3, 1, something it is with this is the reference of this particular object. Okay, so when we are passing, say we have equals operator, right? Equals function. So it takes a box object. Okay, when we are calling this object or this method from a code, when we pass this particular object B here, don't get confused with this one. Okay, A. Okay, I'm passing when calling this equals, right? Say for example, a dot equals of b. When I'm passing this is our this b, this object. Okay, this has this reference using which we access instance variables. We access instance variables. Okay, so when we pass objects to methods, references are copied. Okay, it is a copy operation only, but references are copied here. Okay, we have seen, right? We can assign what to say? We can assign objects to objects, right? So for example, I have box A is equal to no box. Okay, box. Let us make it X. This is Y. Y is equal to X. So in one of the sessions we have seen this one. So now what is happening? What is happening? So the reference is copied to this one Y. Okay, the reference is copied to Y. Whatever the reference that is there in X, that is copied to Y. Now what is happening? Both X and Y are pointing, or both X and Y are referring to the same object. Both X and Y are referring to the same object. Okay, both X and Y are referring to the same object. Okay, similar to that one, similar to this concept, what we are trying to do here, we are trying to copy this B object to this A. Our references are copied. Okay, when we try to pass an argument to this, it copies the reference of B to A. Okay, so whatever the changes that you do for instance variables or state of this particular object, that will get reflected here, where in calling portion of your program. Okay, let us see that example. That then it makes things clear. Okay, let us see an example. Then it makes whatever the concept that we discussed will be clear. Okay, let us try to this see this program. Okay, so we have two methods here. Hope all of you can see this. We have two methods here defined inside argument passing.java file. Okay, one is multiply by 2 and add, and then change box dimensions. Okay, this takes two integers as parameters. This takes box object. Okay, so while calling what are we doing? This is the calling portion of your code. This is the portion that is called. This is the code that is called. Okay, what are we trying to do here? A is equal to 10, B is equal to 20. Okay, so values of A and B before calling, you are multiply by 2 and add. Okay, we are passing A and B, that is 10 and 20. Okay, this method will be invoked. Here I will be 10, J will be 20. That is the values of A and B are copied to I and J. Okay, so here what we are doing some operations. Forget about what we are doing. Okay, we are multiplying by 2 and then we are adding and returning it. Okay, that value is captured here. We can print the sum. So it will be like 20 plus 40. It will be 60. So sum will, since we are returning this value, we will capture that value in this integer. So since we are returning it, to capture the value returned by this particular method, we will use int sum, and that will capture, or the value that is returned by multiply by 2 and add is copied to this value. And we are trying to print the values of A and B after the method is called. Okay, let us see what is the result. Okay, let us see what is the result. Okay, let us not worry about this portion. Let us concentrate only on this part. So what is happening here? A and B, they are 10 and 20. Okay, so a star 2 plus b star 2 is 60, our sum that is written by the method which I told. I star equal to 2 and j star equal to 2. Okay, this is one, and then that is your I star and j star. The I and j are your parameters within the method. Okay, we are changing the value. So changing the values of I and j, but that is not reflected in our parameters or arguments that is passed to the method. Okay, so we are trying to again print A and B. The values of A and B remain the same. It did not change, even though we try to change the value of I and j. Okay, this is what is your call by value. So here argument value is copied, not the reference or address. Address means memory address. Okay, so let us see what is the other type. Call by reference. Okay, so how call by reference happens? The reference is copied. The reference is copied. So as we have seen, what we are trying to do here, we created the default box object, okay, and then trying to print it. So what is it printing? It is printing the dimensions. Okay, -1, -1, -1, because we have used default constructor. Okay, then we are passing this object, default object, to change box dimensions method. Okay, this default object is copied here, passed here as argument. This is your object. This is your object reference. Okay, so when we call that, what are we doing here? We have in our method, right, in our box class, we have different setters and getters for each instance variable, like we have seen in previous class, right? So these are our instance variables, and then yeah, these are our instance variables. Okay, and then we have setters, corresponding setters and getters here. Okay, setters and getters here. Okay, so what are we doing here? We are changing the dimensions inside method. Remember, point to note, inside method we are changing the dimensions here, setting the dimensions. Okay, we are not setting inside the box. Okay, set the box object itself. We are trying to set the dimensions, change the dimensions inside this particular method. Okay, so what is the result that we are getting here when we try to print the object after calling change box dimensions? We are seeing different dimensions here. Earlier it was like this. Yes, now after calling the method, we are seeing this. Okay, we are not printing here. Remember, we are not printing inside the method box, change box dimensions method. We are printing the values here. Here, we are printing the values here. After, before method is called, and after method is called. This is a object that is passed. Okay, so what are we saying? This is passed as we discussed. Objects are passed by reference. Objects are passed by references. So inside this method, whatever the change we do, that reflects outside of that method also. Okay, that is why when you try to print the same object here, this is the initial object. After the method is called, the object has changed its state. Okay, object has changed its state. That is why when you try to print here, it is printing these values. That is what we have set in our change box dimensions method. Okay, so we will stop our session here. So anyone has any questions? So any doubts? Okay, Kavita has a question. Kavita has a doubt. Yeah, Kavita, you can ask your doubt.
Yeah, actually the Java is always said as it is passed by value. But in this method, since we are changing the value in change box dimension by setting, by using the setters, so the value, the changes are reflected in the print line in the default box.
Correct.
But
Correct.
if you don't do anything, I mean, if you just type, if you add up or you do something instead of using setter, then it doesn't change the value, I guess, in default box.
This one you are typing here, right? So if I don't do anything here, the dimensions will be same. Okay, and what you are trying is, if you try to say, for example, I want to print line. Okay, so I want to print line the volume. I want to print the volume of this particular box. Okay, box dot volume. Okay, it prints. I have that method here. Okay, that actually prints the volume. It returns the volume. Okay, so this is what you are asking, right? Right.
Yeah.
Okay,
Yeah.
so one more thing, if you want to do this one, okay, say for example, volume multiplied after multiplied by 2, or after multiplication. What I'm trying to do here is, let me try to do like this. Okay, box dot get depth into 2. Okay, and this is 1. Let us put it in parentheses so that we don't get confused. Okay, into okay, so okay, and then dot get height, get depth, and get width. Okay, so what are we trying to do here? We will try to multiply by 2. Just for example, I'm taking, okay, multiplied by 2. So let us see whether all the parentheses. Okay, when you do like this, right, Control Shift F will align properly. Okay, so what are we trying to do here? Let us see. Okay, each dimension, what I'm doing, I'm multiplying it by 2 and then calculating the volume. Okay, so what Kavita is telling is, sorry, so what Kavita is telling, so -8 multiplied by 2 volume is -8. Okay, this is the values are not changed. After the method is called, the values are not changed. I will explain why. Okay, so here initial volume is -1 because -1 -1 -1 is -1. Okay, here we are multiplying each dimension by 2, so it is 8, -8. Dimension is -8. Okay, And note that we are just using these values. We are just using these values. Okay, we are just using these values. We are not changing the values, or we are not changing the state of an object like we did it here. Okay, like we did it here. What we did here, we are changing the state of an object. State of an object is nothing but your values of your instance variables. Okay, instance variable values. We are changing here, but here we are not doing it. Here we are only using the values. We are only using the values using this particular box reference. Whatever the value that was there, that was referred by this particular object, whatever we passed here, right? The same values we are referring using the getters here. Since we are not changing, the values are not getting changed at all. But remember, notice that we are using the same values. If I change, say for example, let us say on 10, okay, so you can see the difference. Okay, so what am I doing here? So initially it will be, volume will be 1000. After multiplying by 2, each dimension by 2, it becomes 8000. Okay, the values of the dimensions has not changed after we called the method. Okay, but what are we doing here? So this result proves we are using the same values. This is a good point, Kavita. So we are using the same values, right? We are using the same values. So same values which we specified here for cube. Okay, so that means the reference, we are copying the reference of cube to box. We are copying the reference of cube to box to reference the state of the cube object itself, because both box and cube are referring to the same object which has the same dimensions, that is, which has the same state. For example, if I want to make it more clear, so clear if you have any doubts, say for example, I have the cube object here. Okay, height is 10, width is 10, and depth or length, whatever it is, 10. Okay, this is initially referred by cube. Cube is our object. Okay, and when I pass this cube to, say, let us assume the reference is, as we saw, right, in one of the programs, the reference is ABC@123 or something. Okay, so what are we trying to do here? This is the reference which is stored in cube object, which is written by our new operator after calling our constructor. Okay, after calling our constructor. So this reference will be, the reference in cube will be copied to your box. Okay, now the contents, if you can call it as contents, will be this one. Okay, so the reference itself is copied to box. With this reference only, we access these variables or instance variables. Since this is cube is equal to box, means we are passing the reference, right? So references of these two things, cube and boxes, are same. Hari had asked one interesting question a few days back. I told I will explain it later. Okay, we will. I'm still not explaining it with the because they explain that when the time comes. Okay, Hari. Yeah. So what we are doing here, we are trying to copy the reference to box. So when you try this box is equal to cube, it should return true, because this reference is the content of this box. Both are same. Okay, and this reference we are using, that means when we copy the reference to box, both are pointing to the same object. Okay, both are pointing to the same object that is in the current state. Current state of this object is height is 10, width is 10, and dimension is 10. Okay, the same reference is being used here also. The same reference is used while passing, and if you want to print the values, right, it is printing the same values here, right? The same values, whatever the value that is, okay, whatever the value that we are printing here. So initially when we printed, we are printing the state of cube object. After calling also we are printing the cube object, but inside method we are just referring the states of cube object, so that it again proves that the references are copied. Okay, again what are we trying to do here? The value, if you can assume the value of cube as a reference, we are copying the values only, that is the reference. Are you getting, Kavita, what I am trying to explain? Did you get my point, Kavita?
Yeah, yes. Actually, I mean to say that it is changing when it is passed by values. In that way, I was thinking, because in set.
No, whatever is happening, right? We are copying whatever the content is there. Here we are content of I or content of A and B are copied. Okay, contents of A and B, that is variable. Okay, here also the contents of object is copied, right? That is a reference. So references. Okay, we are passing references. When we talk about references and change the values, right, of a particular object, that obviously it reflects in the any other object which is pointing to the same object. Like we had this one, right? So we had cube, and after passing the reference to this particular method, box is also pointing to the same object. Okay, so even if you try to change the value of cube using cube reference here and pass it here, the same values will be referenced by box. Even if you change the values here and reference it by cube, the changed values of box will be reflected here. Okay, so how that is done using your references, not by primitive copy. Okay, so even though we are copying the references, even though we are copying the values of objects, that is references, if you make changes through reference to the state of an object, that reflects in any object that is referring to the same, any identifier or the instance, say object only, I can call object only. Okay, so any object that is referring to the same reference, right, it is reflected everywhere. Even if you have another box object, say for example box Y, and I will assign box to it and change Y. Say instead of box I'll put B. Okay, instead of box I'll put B. Sorry, Y. Okay, Y. If you try to print box after this, the change values will be different. Like if I set the values right, the values will be different for box also, for Y also, for cube also. For that matter, let us try to do that also. Okay, say for example, let us define another box. Y is equal to box. Okay, and then let us make this as Y. Okay, so what am I doing now here? There are three objects: cube object, which is passed to this method, and I'm copying the reference of this box object to Y. Okay, and then I have set the values. Let us put this, let us comment these parts. Okay, we don't need them. Let us comment these parts. So let us try to print ls box okay, then okay, let us try to execute this and see. Okay. Okay, so let us do one thing here. Okay, so here before calling, okay, this is box object. So dimension has changed, right? Box object. This is our box object. Inside, change box dimension. So how did we change that box dimension? These are all very important concepts. Okay, so better to concentrate on these things. Okay, so how did we change this object? So practice this thing. We change this object using Y object. Okay, not with box object. Okay, say for example, if cube has x, y, z as its reference. Okay, y will also have x, y, z, and box will also have x, y, z. Okay. That is why these are all references, right? References are used to access the actual values that are there in your this one. What is that? In your memory location, right? That is why when we change these values, since all are referring to the same object, if you change the values using y, the values of box is also changed, the value of y is also changed. Okay, the value of cube is also changed here. Okay, value of cube is also changed. So this is my this is for our object types or complex types. Okay, whichever the identifiers that qualify as objects or complex types, this is how the call by reference applies. Okay, do you still have any doubts or questions, Kavita?
No, I don't have any.
Okay, Kavita, yeah, thanks. And he is asking, he is telling something. So he is telling because the instance variable is private, the only setter can access the value to change it. Yeah, we cannot. Yeah. So here what we have done is, so we have used this, right? Private. Okay. So private, by making private, what we are doing, we are not allowing this instance variable to access anywhere outside of this particular class. Okay. By making this as private, we cannot access this instance variables outside of this box class. Okay. That is why we have our setters and getters here, public setters and getters. Okay. So public setters and getters are the interfaces through which we can access instance variables. We can change the state of an object. Okay, you need for some instance variables we can provide both setters and getters, or for some instance variables we can only provide setters, or for some instance variables we can only provide getters. Okay, those all things we will discuss in future sessions. Okay. Okay. So anyone has any other questions or doubts? We can discuss that. Okay. Otherwise, we will stop the session. We'll conclude this session. Okay. Okay then. Let us conclude this session. So tomorrow also we will have class at 10 o'clock to 12 o'clock. It is 11:59. It is mentioned, but we'll have till 12 o'clock. Okay. So if I want to cover more topics, I might extend the sessions. Okay, so maybe 12:30, 1 o'clock. Okay, till 12:30, 1 o'clock. Shanti is asking, sir, can you please upload the PPTs into the drive? Yeah, Shanti, you need to discuss with Yuvraj regarding PPTs. Okay, please discuss with Yuvraj. You send an email to Yuvraj, so he would be able to kind of like respond to you. Okay. Okay. Yeah, Shanti. Thanks a lot. Thanks, Kavita. Okay, then let's start this session. Okay. Thanks everyone. Thanks for attending. Tomorrow also 10 to 12. If I want to cover more topics, I will take till 12:30 or 1 o'clock. Okay. Thanks everyone. Thank you very much.